Hey friends, it's Mrs. D, and I just want to go through a couple things. I know some of you are struggling a little bit still with sig figs, so I just want to briefly go over some examples, make sure you're good to go, so you're ready for that awesome test tomorrow. So let's take a look at some sig figs. Quick review. Let's say I have 1.250. How many sig figs do I have? 1, 2, 3, and 4 sig figs, because that zero trailing a decimal on the decimal side is significant. However, if I have 1,250, I only have 3 sig figs because my decimal's here, and notice there is no decimal. So therefore, that trailing zero on the left side of what would be a decimal is not significant. Let's say, for example, I have 120.5. If I have my zero here, because I have that decimal, that zero is significant. So I have 1, 2, 3, 4 sig figs. Let's just kind of keep with these numbers here. And let's say I have 1.2 and then I have 0.0. If I have my decimal point with a zero, that does show that this number is significant, as well as the trailing zero is significant because of the decimal point. So in this case, I have 5 sig figs. So just a little reminder, if I have trailers, trailing zeros when there's no decimal are not significant. Trailing zeros when there is a decimal is significant. So another thing, sandwich zeros, anytime you have sandwich zeros, so if you have them stuck in the middle like this, they are significant if they're between two counting numbers. So you have 4 sig figs here. If you have something like a starting zero, so say you have 0.001205, these two numbers, these two zeros are not significant because they're simply placeholders. So we still have 4 sig figs here. So we would consider this to be 4 sig figs. So again, sandwich zeros are always significant. Placeholder zeros are not significant, ones that like set it up at the beginning. If you have trailing zeros, like you have here, with a decimal, it is significant. Trailing zeros without a decimal is not significant. That's where you have like 3 million, for example. And if you have this, you have 1 sig fig, even though you have this huge long number. If you have 3 million, oops, 0.0, then you have 7, 8 sig figs. That much makes a difference, because if we go to the struggle of doing 0.0, then this must make a difference. Okay. All right, let's take a look at some problems real quick. Sorry about that. Let me go back here. Let's go back a slide. All right. So let's take a look at some problems when we do addition and subtraction and multiplication and division. So first off, let's just do a quick addition. Say we have 1.82 plus 7.3 plus 16. So what we have to look at is we have to say, okay, we have 2 decimal points here, we have 1 decimal point here, and we don't have any decimal points here. So we're going to add this up, and when you do add it up, you're going to get 25.12. Now, how are you going to express that? So notice we don't have any decimals here, so we have to go with the smallest amount of decimals produced. And so since there are 0 decimals here, we have to round this to 25, because looking at that 1, it's going to keep it at a 25. So our answer would be expressed as 25. Let's say I had something like 2.0 plus 4.5 plus 3. I'm still going to have, if I add these together, I'm going to get 9.5. However, I'm not going to keep that 0.5 because 3, there's nothing after it, and that's in the ones place. But that 5 is going to make that 9 round up to be a 10. So my answer would be expressed as 10. I don't have any decimals after the counting number here. If I were to do multiplication or division, let's say I have 42.1 times 0.036. What I have to do with multiplication division is I have to actually figure out my sig figs in the numbers that I'm multiplying or dividing by. So here I have 3 sig figs, and here, notice I have a placeholder, so I only have 2 sig figs here. So I'm going to go ahead and multiply that out, and I want to keep 2 sig figs because I only have 2 here, and that's my lowest number. So my answer is going to be 1.5, okay, with 2 sig figs. What if I have something that, for example, like a big one, like we did in class a couple times, 38.6 times 2, let's say it's 14.9, and we'll multiply that by 0.002. And let's add that to 21.2 times 3.2. So we kind of have to take this in chunks. So this first one, we have 3 sig figs here and 1 sig fig here. So if we take 38.6 times 2, we are going to get 77.2. However, because we're multiplying and we only need 1 sig fig, how can we express 77.2 with 1 sig fig? So what you do is you say, okay, I can round it here. So I can't round it to 77 because that's 2 sig figs. So instead you have to take, look at the 7 here, and that's going to make that go up. So your answer for that section is 80. Then you have 14.9, which is 3 sig figs, plus 0.002, which is just 1 sig fig. And so you're going to get 0.0298, but we only need 1 sig fig. So we're going to look at this 9 that makes that 2 a 3. So we have plus, 0.03. Then we're going to add that here. We have 21.2, which is 3 sig figs, 3.2, which is 2 sig figs. So we need our answer expressed in 2 sig figs. And when we multiply that, we get 67.84. And so that rounds, if you look at that 8, it's going to make it 68. And we want our answer expressed in 2 sig figs because we have 2 sig figs here. Now, if we add all these together, now we're doing the addition. So we have 0 decimal points here, 2 decimal points, and 0 decimal points. So we need to do something where we end up with 0 decimal points. So basically, we're going to add 68 and 80, and we'll get 148. And that's going to be our final answer, is 148. So through all that, you had to figure out your sig figs. Just take it one step at a time, find the answer, figure out what sig figs to go on to the next type of problem. Okay, you guys can do this. I trust that you can absolutely do this. So hang in there, and you'll get it. I promise. Take care.